This is chapter 5-3, medians and altitudes of a triangle. Please copy your cuts. To begin, I have triangle ABC, and I'm looking at segment AD. Segment AD is a segment that bisects the segment BC on triangle ABC. Again, segment AD is a segment that bisects segment BC. Remember, the word bisects means in half. Therefore, BD is congruent to CD. Okay? It's bisecting at the midpoint, so segment AD is called a median of the triangle. Segment AD starts from the vertex of the opposite side, bisecting and intersects at the midpoint. So, segment AD bisects line segment BC. But this median of the triangle, two things happen. Number one, segment AD bisects BC exactly in half, and it must come from the opposite vertex. So the angle opposite to line segment BC, the angle opposite to this segment BC is angle A. Therefore, line segment AD is constructed from the vertex A and drawn to the midpoint of segment BC. That makes it a median of a triangle. Okay? I can also draw another median of the triangle for line segment AC. If I want a median of a triangle for AC, two things need to happen. I need the angle opposite of AC. The question is, what angle is opposite to side AC? Well, the angle opposite is angle A. So if I were to draw that, that means I have to start at angle B, and it must be in the middle or midpoint of line segment AC so that it divides AC exactly in half, and again, it comes from the opposite vertex B. Okay? So let's look further. That's how you construct the median of a triangle. So now I have this triangle ABC again. And when I look at this here, if a triangle has all three medians constructed, then their concurrent, you need to review what the word concurrent means. Their concurrency intersection is called the centroid of the triangle. That's point P. So now I have all three medians drawn. AD bisects line segment AC. Again, it makes it, it's in the middle. So BD is going to CD. And this segment AD is drawn from the opposite vertex of line segment BC. The opposite angle, of line segment BC, the opposite angle of BC is angle A. So I draw it across, okay, to the opposite side, which is BC, and I draw it right in the center or midpoint. The same thing with AB. Okay, if I want the median, I need to look for line segment AB. The angle opposite is angle C. Here it is. And it's drawn to the midpoint. And finally, AC, which I drew in the previous example, AC, okay, is being bisected right here, and the opposite angle is B. Okay, and there it is. When all three of the medians are drawn, that means I have a centroid of the angle. The concurrent point is the centroid of the angle, point P. And here is a theorem for you. Okay? And the concurrency, here we go. Theorem 5-7, concurrency of medians of a triangle says that the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So what does that mean? If point P is the centroid of triangle ABC, when I look at, if I look only at segment AD, this whole segment, the first one I constructed, and I can go, well, I look at AB. That means that AP is 2/3 as long as PD. It's 2/3 of this length of AD, So that means that, let me use a color. That means AD is 2/3 and PD is 1/3 to make the full line. Same thing with BE. That means that BP is going to be 2/3 of the line, and EP is 1/3 of the line. And finally, when I look at segment CF, when I look at that, that means that CP is 2/3 and FP is 1/3 to make a full 3/3 or 1 whole. Let's try some examples here. Let's say I have this triangle, such that I have triangle ABC again. And I know that these are all congruent. I know that CF is the median because AB is evenly divided on both sides and is drawn from the opposite angle C. If this is true, and I found that the concurrent point, the centroid point P, is located here, if I say that PD is equal to 4, and I'll draw this out, PD is equal to 4, what is the length of AP? Well, remember what we said, that AP is going to be 2/3 the length, and DP is 1/3. Well, if this is 4, that means to make this a full length, 4 times 3 will be 12, okay? We'll look at it that way, or this will be another 4 here, and that'll be another 4, so that means that AP has to be equal to 4. Excuse me, sorry, not 4, 8, excuse me, okay? If I divvy this into 3 parts, 4 times 3 is going to be 12. That means that each third is going to be worth 1/3, 1/3, and 1/3 is all equal to 4. So 4, 8, 12. This is 4, that's 4, and that's 4. And both these two add together give me the 8. Okay, you may see it another way. Okay, and again, as I stated, 8 because PD is 1/3 of AD. And if I say, if I'm looking at BP now, if I look here at, if I look at BP, okay, I'm already thinking, because this is going to be my centroid here, I already know the BP is 2/3 and the EP is 1/3. Well, if I know that BP is 2/3 and I know that BP is 10, what is the length of EP? Okay, if I take half of this here, half of 10 is going to be 5. That means that each third is 5, 5, 5 to make 15. That means that EP is going to be equal to 5. I'm hoping this makes sense to you. Okay, because I'm dividing it into thirds. Okay, so 5, 10, 15 for the full length. So if I ask for the length of BE, the full length of the entire segment is going to be 15. EP is 5. BP was given to us as, where did it go? 10. And I believe that I've asked that CP. Let's look at CP here. If I have here that CP is equal to, if CP is equal to 11, what is the length of CF? Okay, so if I have CP is equal to 11, what is the length of CF? So if I take that 11, divide it in half, I can find out how much this is worth. That's going to be 5 5/10 for each 1/3. So that means that this will be 5 5/10. This is 5 5/10. And this will be 5 5/10. 3 times 5.5 or 5 5/10 will be 5, 10, 15, 16 and a half. Okay? And there should be that. And then next here we have a triangle. And then the altitude of a triangle is the perpendicular segment from the vertex to the opposite side or to the line that contains the opposite side. The altitude can lie inside, on, or outside of a triangle. Every triangle has 3 altitudes. Okay, the line that contains the altitude are concurrent, and their intersection is called the orthocenter of the triangle. So point G is going to be our orthocenter. Okay? First of all, altitude. When I draw an altitude, that means two things happen. Okay, the altitude of line segment AC is going to be BF. Again, I'll say that. The altitude of line segment AC is BF. The altitude BF, altitude means I want a perpendicular line drawn. That means BF is perpendicular to AC. There's my right angle. I need a perpendicular line, and it must be drawn from the vertex of the opposite angle. So what's the angle opposite of AC? It's B. Well, if I want an altitude, that means I'm going to start from the vertex B and draw it straight down such that I get a perpendicular line formed on there. Okay? I can do that for each and every side. So let's say I want to look at BC here. BC has an altitude there. Okay? The altitude is AE. The altitude is AE. Remember, altitude means I'm looking at BC, and if I want an altitude, I have to draw it from the angle that's opposite of BC. Well, which angle is opposite of BC? Angle A. Remember, altitude means the angle opposite, and it must be perpendicular to that line. So AE is perpendicular, right angles, to BC. So I've drawn it from the opposite angle, and I've drawn it perpendicular to BC. And then my third and final altitude is BA, or AB. Okay? Or, excuse me, not the altitude, but the last altitude is BD for line segment AB. So, what is the altitude of line segment AB? It is CD. Okay? Remember, altitude means if I'm looking at AB and I want an altitude for it, I have to find the angle that's opposite. Well, which angle is opposite to AB? It's angle C. And I must draw it perpendicular to AB. And there it is. Okay? It's CD. Where all three of the altitudes intersect, it's called the orthocenter of the triangle. The orthocenter. And if this triangle, such that it is, it's an acute triangle, on this acute triangle ABC, acute triangles, the three altitudes where they intersect, their orthocenter, point G, will be on the inside of a triangle. It will be on the inside. Well, if I draw three altitudes on a right triangle, the three altitudes concurrent point is point J right here. So that the orthocenter will be on the triangle. Here it is. Okay? Please know that LM, okay, LM and KM are already used twice. Those are legs of a right triangle for the triangle KLM. They're right. They're already right angles. So if I draw the altitude, let me see if I can delete this. Okay, so if I'm looking at LM as a side, it's already an altitude because it's a straight. It already forms a perpendicular line. So there's no new line segment you're going to draw. It's used twice. LM is used as part of the triangle KLM. And it's also an altitude because it's on a right angle. Okay? Same thing with KM. KM, when I draw a perpendicular, well, the perpendicular line, it already forms a right angle with LM. So it's also a part of the triangle KLM, and it's an altitude. So it's used twice on a right triangle. So two legs will be used twice. Okay? And the orthocenter, again, is point J. And it's on. The key word on this one, when you have a right triangle, the orthocenter will be on. And then finally, on an obtuse triangle, and the obtuse, let me delete these here, delete the legs so that you can better see here. Okay, on the obtuse triangle, PYR, the obtuse angle is Y. Okay, on an obtuse triangle, the three altitudes concurrent point is going to be W over here. And I'll put those points back in there. Okay, so the orthocenter is W. Okay, and on an obtuse triangle, the orthocenter will be outside the triangle. Okay, and here's the concurrency for altitudes of a triangle. The lines containing the altitudes of a triangle are concurrent. So if YQ and PZ and RX are the altitudes of triangle ABC, well, I should put PQR, excuse me. PYR, excuse me. PYR. Triangle PYR. Then the lines YZ. Where was my YQ, excuse me. Then the lines YQ, this line here, and PZ and RX intersect at point W here for your Orthocenter. And it sounds weird, Orthocenter, even though it's on the outside. And this is your 5-3 lesson.